Hello, this is a video on the concept of resolving forces and what's going on. Particularly, we've got lots of multiple forces, and like an example here, I've got a box on a rough inclined slope, and what's going to happen to it, what forces are on it, which way is it going to go, and we're going to look at the what standard forces are we use, and also how we resolve forces and what that really means. Let's have a look at this setup here. So here I've got an object, it's got four forces operating on it. On the left hand one, the forces are nice and neat, aren't they? Because there's some forces operating in the y direction, some operating in the x, and that makes life easier. In the right hand example, we've still got forces and they're all at right angles to each other, but they're not horizontal and vertical anymore, are they? They're over an angle, and we'll come back and think about that. But in our world, we can start to consider forces horizontally and vertically and how they're having effect. So let's have a look. Okay, here we go then. Here's our diagram. I've put some values on here. So my blue force is 30 newtons and my green force is 30 newtons. So if I start thinking about what's happening vertically, they've got two forces operating and they're going to balance each other out, aren't they? So there's going to be no movement vertically. Does it matter what's happening with these horizontal forces in that terms? No, because they're operating in a different direction. They're not going to make us go up and down, are they? They're going to make us go left and right. So the first fundamental concept is we can just look at forces in two perpendicular directions. Yeah. In this case, we do our verticals first. That quite often happens if we've got weight and normal reaction. We'll come on to that in a bit. But that's the sort of thing we might do. So this body isn't going to move vertically, and it doesn't matter about the red and purple forces in those terms. So now let's have a look at what's happening horizontally. Well, I've got a horizontal force here of 40 newtons to the right, taking me to the right, and I've got some sort of resistive force, say, of 15 newtons, sort of trying to stop that happening. What's going to happen here? Well, it is going to move to the right, isn't it? Because 40 is greater than 15, so if I took one away from the other, I've got a resultant force, what's called resultant, yeah, the 40 take away the 15, I've got 25 newtons trying to move me to the right here, this body to the right. And again, the blue and the green have no effect on this. They're going in a different direction. We're only interested here in forces that are going left to right. Yeah, and we can calculate our resultant force here by just looking at those and ignoring the rest. Okay, let's extend that idea a bit further. Here's exactly the same forces, we've just turned them around slightly, and by turning the whole set round anti-clockwise by angle theta. Yeah. Now I could spend lots of time going horizontally and vertically, but actually, can we see that intuitively, if I just look at that slightly off vertical here, going in that direction, I've still got my 30 newtons here, being balanced out by my 30 newtons there. So going in the direction of my green arrow here, nothing's going to happen, yeah? All the forces are in balance. Doesn't matter about the red and purple forces because they're perpendicular to the arrow that I've just drawn. So they're not relevant. Secondly then, let's have a look at this slightly off horizontal. So we're now going in that direction, probably where my orange arrow is pointing there. Well, in this direction, I've got my 40 purple newtons going that way, and I've got my 15 resistive. So I think we can see again that I've got a resultant force here, 40 minus 15, so I've got 25 newtons moving me in that direction, yeah, along the line of that arrow. It's not moving me purely horizontally, as it's taking me up slightly as well, but it's going in the direction. So this body's going to accelerate in the direction of that force there. Yeah, it's going to go up at that angle theta. That's what's happening here. So that was quite simple to think about, wasn't it? And we can see fairly quickly that we've got this resultant force again of 25 newtons, and it's just going up at this angle theta. So that's the way the body's going to go. And that was quite easy to do, wasn't it? If we think about that as almost as rotating our axes. We could spend a lot of time on this diagram here splitting our forces into their vertical and horizontal components and seeing what happens. So we could take this 15 newtons resistive force and we could split it up in vector terms, couldn't we, into two separate vector forces. Here's one, that's our 15 cos theta, and we've got another piece of force here which is our 15 sine theta, yeah, and if we add those two together we get this force here. Now we could do that for each of the forces and then we could try and resolve see what our forces are horizontally and see what our forces are vertically, but that's really complicated and difficult, and it's much easier to do what we did earlier, isn't it, to choose the directions that we want to resolve in to make our calculations easy. So here, almost like we've canted over or turned our axes. So what do we want to do then generally? Well, we're going to carry on and use that idea, and I'd suggest it's quite a good idea to think about our axes are effectively turned and we want to make our life easy. So we can quite easily see here that our blue and green forces are in balance, and so we're not going to go off in that direction, but our forces are not in balance going over to the right and slightly up from the horizontal, and we've got a resultant force of 25 going this way that's going to move our body in that direction. So I think that's an easy way to think about it. So just our quick summary here then, we can resolve forces in a particular direction and we can have groups of forces and we want to find our resultant forces. So but key points: forces in the y direction, the y-axis, do not affect motion in the x-axis. Yeah, they're perpendicular to it, they're having no effect. If we want to find out, if we find the forces going in the x direction, the x-axis, they're going to affect the motion in the x-axis. So therefore we resolve all our forces in the x-axis to find our resultant force in the x-axis or in any axis that we choose, and then that gives us, we can use that to find our acceleration. And in practice it's best to resolve it at any angle or direction that's simple to do it, like in this case over here, and we can effectively do that by thinking about rotating our axes, aren't we? And that's basically what we're doing. We're going to do it in our most simple way to find our resultant force, so we can put it into F equals ma, Newton's second law, and then we can find what our acceleration is. So there you go, that's the first concept. In the next part I'm going to show you some examples.